Okay, how to solve problem in chapter 2. As I mentioned before, three-phase diagram. The first, no-solid solution, limited solid solution, and also isomorphous. Step by step to solve problems. The first, find phase presence. Second, find composition. Next, calculate weight fraction or calculate weight amount or relative amount. This is the same meaning. Sometimes using a level rule. Okay. Next, draw microstructure. And the last one, draw and label cooling curve. Exercise. Determine the weight fraction on each phase in the copper 50% nickel alloy shown in figure at 1400 degrees Celsius, 1300 degrees Celsius and 1200 degrees Celsius. For this exercise, you have the two important things. The first, you need to consider this composition. This composition is a copper 50% of nickel. So 50% of copper, remaining 50% of nickel. Look this graph. This graph is this is a copper and this is a nickel. All this value belongs by nickel. So make a straight graph 50% of nickel. Next, you need to consider this temperature. There are three temperatures here. So please solve one by one. For example, I choose 1400 degrees Celsius. 1400 degrees Celsius, make a straight line and then you can get this region. So to solve this problem, please write down at 1400 degrees Celsius. One phase present. So your phase present is here. Liquid. Your last answer L. Liquid. 2. Composition. For the composition, you need to find the C note and also Cl only. C note is your first composition here. 50%. Your answer 50% of nickel. Then composition of liquid also 50%. Also 50%. 50% of nickel. This question asks you weight fraction. To solve weight fraction, you need to find out the phase present, number 1, and also step number 2, composition. And then you can find the weight fraction. So, then liquid in this region. How percent liquid in this region? So, WL, weight fraction of liquid. Your answer is a 100%. Next, 1300 degrees Celsius. So, at 1300 degrees Celsius. Same as before, first find the phase present. Okay, before you find the phase present, please make straight line to the 50% of nickel and temperature 1300 degrees Celsius. So this region is a SS plus with the liquid. SS is a solid and L is a liquid. Second, find the composition. So you have C node, you need to find C node, CSS, and also CL. So C node is your initial composition. C node is a 50 with percent of nickel. How about the CSS and also CL? If you look here, you have the liquidus line and also solidus line. For the solidus line, you can find the value of solid, CSS. And for the liquidus line, you can find the value for CL. So, this line for your left side is a CL and for your right side is a CSS. How to get the value? Downward, make a straight line downward for both CL and also CSS. You can find this is a for the CL and this value for the CSS. So, answer for the CSS, 57% of nickel and CL 44% of nickel. Weight fraction. To calculate weight fraction, please use lever rule. So your lever rule, this is for your left side is a CL. For the right side is a CSS. In between CL and CSS is your C node. You can find WL and also WSS. Now find the formula for the WL. WL equal to, you close CL, you can get the CSS minus C node over overall CSS minus CL. Now find the formula for the WSS. You close CSS, you can get C node minus CL over CSS minus with the CL. Now put your value CSS 57 minus 50 over 57 minus 44. You can get answer. Second, WSS 50 C node 50 minus 44 over CSS 57 minus 44, and then you can get answer. Okay, last 1200 degrees Celsius. This is the first step, 50 weight percent of nickel, and 1200 degrees Celsius is your temperature. You can get this region, and 1200 degrees Celsius, first phase present. Your answer is a solid solution, SS. Solid solution, SS. Number 2, composition, C0 and also CSS. At 1200 degrees Celsius is a solid solution. For the composition C0 and CSS, same value for the 1400 degrees Celsius. So your answer C0 is a 50% of nickel, and CSS also 50% of nickel. Here, 50% of nickel. Number 3, weight fraction. WSS means WSS, weight fraction of the solid. You need to find the percentage of this region for the solid. So your answer 100% of solid.